integration by partial fraction. Okay, this method applies to integral of rational functions. So integral containing rational functions. Now you may come and say, wait a second, isn't it just what we've been doing? For instance, look at the last example. This is a rational function, x over the square root of something. So we've been doing that. The problem is, we know how to use trig substitution if we have one of three forms: square root of x squared minus a squared, square root of a squared minus x squared, square root of a squared plus x squared. Now we can use some clever techniques such as completing the square and such that allow us to, in some cases, to take a rational function and convert it into one of the three forms. But there are other cases where this is impossible. So we need to do something else. And let me just start with a quick example to demonstrate the idea behind this technique. So here's an example. I call it example 0, because really I'm not starting yet. But in this example, I'm going to start with a simple operation. We'll do subtraction. I have one rational function that is 2 over x minus 1, and I want to subtract another rational function, 1 over x plus 2. Okay? Since x minus 1 and x plus 2 do not have any common factor, then the least common denominator will be simply the product of the two denominators. So it will be x minus 1 times x plus 2. So I need to multiply 2 by x plus 2, and I need to multiply negative 1 by x minus 1, and clear the parentheses and get to 2x minus x, so you have x, and then you have 2 plus 2 times negative 1 times negative 1, or 4 plus 1, so the numerator is x plus 5. The denominator, we have x minus 1 times x plus 2, so we end up having x squared, 2x minus x, so plus x, and minus 2. Okay? And this is the rational function that is the result of subtracting two other rational functions. So now I'm going to try to integrate this x plus 5 over x squared plus x minus 2 dx. And here's the idea behind partial function. If you are given this rational function and turn out that you can factor the denominator, and every polynomial can be factored as product of linear function or quadratic functions. That's an algebra theory that we're going to address again after this exercise. Then, if I can factor the denominator, then I can write it as a sum or product of partial fraction. So I know that now I need to go in reverse, and going in reverse produce the integral of 2 over x minus 1 minus 1 over x minus 2 dx. Now each integral by itself is easy. X plus 2. Thank you. The integral of 2 over x minus 1 will be simply 2 times the natural log of x minus 1, the absolute value of the natural log of x minus 1, and then this will be the natural log of x plus 2, plus c. So this is the answer.